rotation. And it makes a lot of calculations a lot easier, of course, because we will not have to deal with quaternions. We recently did the Ross workshop, and they spoke about quaternions, and almost nobody in the team knew what quaternions are about. So they are a way to work with rotations in three-dimensional space. And the great advantage of those is that they avoid singularities. When your corner approaches 90 degrees in any direction, you are likely to run into problems with your calculation, and quaternions solve that. Well, okay, in a flat surface, all you need is the aton I y comma x function, and that will solve all singularities, so that makes it easy. And only the ball can leave the plane. Yeah, I've heard one team speak about the ball that's off the ground so far. I think there's a lot to solve in that area. I'm glad one team at least is thinking about how to solve that. So this plane, it turns out to be a difficult problem, not only for us, but also for the Daleks. And that's probably why we are safe from them, because when they met the staircase, that was the end of their mission to conquer the universe and exterminate everything that's not a Dalek. Okay. Well, not a very deep technical discussion from my side. This is about all I wanted to tell you. So if there are any questions, you can fire them now. And if you want to look on the internet, here are our website and also where you can find the drawing of Dalek.
Yeah, you mentioned about the round robin implementation. That means that you don't run on an operating system?
Yes, we do. We run under Ubuntu.
Because Ubuntu has its own scheduling system, but you also use it. So how does it work? Yeah, how do you make sure that they don't bite each other?
Our process simply runs by itself, and it doesn't look at the environment at all.
But the process running on Ubuntu?
It is, yeah.
So if you are doing some scheduling, Ubuntu itself can also schedule your process away and then give some other process. So how do you prevent that? Because are you running the real-time kernel or?
Willem, do you know that?
Yeah, it's a single task. So everything is processed in one block.
It's a single threaded process.
Round robin means that.
But on the Ubuntu there are different processes running alongside.
Yeah, definitely. Yeah,
so what if one of those other processes gets computing power? Then you cannot guarantee any real-time behavior anymore.
No, we can't.
No, you're right.
You're right.
You're absolutely right about that. Yeah.
They probably run on a different processor as well.
So you were talking about the interesting parts of the field, and you mentioned opponents and ball, but I would say that the open space, the free space, is the most interesting.
Because that's where you want to go.
Yes.
Okay.
So now, the question actually is, how would you grade the interesting parts? Yeah? So I think the whole field is interesting. Okay, that.
As I said, the details of the planner are all in the head of Jurgen van Eyck, who you will meet tomorrow.
He has a big head, so.
Too big?
Yeah?
I have a question regarding your batteries. Do you know the capacity?
I think it's 36 volts, which would be about 10 cells. I'm not completely sure of that.
We normally run all evening with it, and then we don't have to charge.
because our robot
you
spends a
don't
lot of
know-
time on the middle dot.
But you don't know the capacity bar.
No, I don't know. No, maybe we can have a look tomorrow. Maybe it's on the battery.
What is the charging time when it's empty? Because it's
From
wired.
Wednesday to Wednesday, I don't know.
But it's a wired system, right? So you have to charge on the robot. You cannot not simply replace the batteries.
No, we can't.
So then it's important in a competition situation on a championship that you can really charge in a very short time, because you will probably not have enough to play the whole day.
I don't know. Yeah, I've never been in any championship, so I don't know in a whole day how many games.
Let's say that you play a game and batteries are empty, and then 1 hour later you have to play again.
Yeah, but I don't think our batteries are empty after one game.
No, I have the impression they will last for at least 2 games of a lot of activity.
Okay, so then you have the problem after 2 games.
Yeah,
Maybe.
maybe, yeah.
Yeah, but they're not empty, so you don't have to fill them up completely. So the
Yeah,
time you
yeah,
have.
well,
To,
it
but
would
I don't
be-
know. We have to.
It would be interesting to know how fast you can charge.
Yeah.
I think we still need to gain a lot of experience in practice with that. Yeah.
So in theory it looks perfect. There are some restrictions around those batteries. People are afraid of them. So are you allowed to take them, for example, to China on a plane? I mean,
Yes, you are. Yes, you can.
okay. Oh yeah, there was. I mean, people are afraid of them because they burned in the plane.
Yeah, but these are live posts, right? You have lipos.
Yeah, that's
And
right.
lipos are worse than live posts,
Yeah,
right?
that's right.
Yeah, but
That's
people are
true.
Manages to get one.
That's true. As I said, our batteries are falsely
Yeah,
accused of this fire. But of
Yeah.
course, with batteries, you always have to be careful. People think, oh, it's a low voltage, it's not dangerous.
Yeah.
Well, you try to put a spanner across the poles of the car battery and see what happens. That's not nice. Batteries are very
It is
dangerous
specific
in all
rules for
situations.
transporting these type of batteries, and you have to comply with them.
Hmm.
And as long as you do, there's no problem.
Okay.
Are you using them in series?
Yeah, they're connected in series. Yeah, that's correct.
Do you think that actually changing the batteries would be a foolproof solution? Because we have a type of connector that it's impossible actually to swap.
Yeah, well, you know, I've been wondering myself, because there are 3 pins, so you can wire them in such a way that no matter how you connect them, it will always come out right. I have no idea. I know I managed to pull them wrongly.
Oh, you did? Okay. Alright. Because actually we are also, it's not implemented yet, but we also have a inboard charging system that can take care of charging all the batteries without having to take them out.
Okay.
But in the end, maybe you come to this situation where the batteries are on low level and you still only have half an hour or 40 minutes until the next game, and then the possibility of actually changing them is the only solution. Or then you charge them with a high current, and that's quite dangerous. Because with this kind of batteries, if you can actually change them as something like 5C, which can go in a battery like this with 200 or 300 amps. But you have to take a lot of care with temperature, otherwise you come out with a fire or an explosion.
What the supplier told us is that you can take a set of spare batteries, but you also have to maintain them all the time. Who guarantees you that you maintain them in the right way? And you also have to use them from time to time, because you cannot take, if we have 6 robots, a 7th as a spare. No, then sometimes you have to use the 7th also. And he said, so start with 6. Okay? At this point we believe him.
No more questions? Maybe last question. Will you go to China next year?
We still hope to, yes.
No, our plan is to go. Our plan is to go.
Yeah, that's correct.
Are you going to China next year?
Thank you very much.
We'll continue with CAMBADA.
And that's the last team presentation before the talk by Harold. Okay, so some of you were on the workshop last year. We showed you some of our ideas to improve our architecture on the agent, and that's what mainly I will be talking about in this presentation. I will present you, now that it's finished, our new architecture, and I will also disclose some of our behaviors that were implemented in this new architecture. So this is the outline of the presentation. I will introduce you to the older architecture and show you what problems we found on it. Also present you the new architecture and develop behaviors on it. We started using heat maps. We can use cost maps or utility functions, wherever you want. Also present you some results and then draw some conclusions. Starting with the introduction. This was our old architecture. And from the point of view of the execution flow is as this diagram shows. So, bottom-up perspective, we have the behaviors to execute a specific task, like moving to a point, dribbling the ball, kicking, passing, etc. Then you have the roles, which use these behaviors to play a role in the game, like being the striker, defender, or midfielder, receiver, etc. Also the goalie. And they were instantiating behaviors via a finite state machine at each cycle. Then we had a decision with a lot of if-else statements to instantiate also a role at each cycle to select for that particular agent or robot what role to take. And this decision layer, what we call decision layer, or the agent itself, needs to output this set of variables, the velocities in x and y, on our x and y coordinates, also the angular velocity, the power for the kicker, and also a grabber state. What problems did we find on this architecture? So, first of all, history loss, since the behaviors and roles were being instantiated at each cycle, and every cycle was a new world for the agent, with some exceptions. And also a high code complexity, especially on the roles with hundreds and hundreds of lines of code, which made us a very difficult task to adapt to new rules. So it was sometimes a nightmare. So how did we came to a solution? So we introduced 3 new submodules, and I will go into detail from bottom-up perspective again. So the drive vector is mainly a class that holds the low-level information to send to the hardware. It also has a set of functions or methods that we can use to change that to variables easily. Then we introduce the controller. So the controller receives as an input a target, position or orientation, and via PID controller calculates the x, y, and angular velocities. And we implemented 4 different controllers. We can implement more, but now those are the ones that we have. Also, the controller gives us that flexibility to exploit other types of controllers in the future in a very flexible way, so that every behavior will use that new controller. So the behavior will also had some changes. We also talked about the Tribots team. We followed some of their ideas, and back in 2008 to 2009, they had a presentation which is still on the website called Behavior-Based Approach, in which they extended the interface of the behaviors to include some conditions. So what we had before was the conditions to invoke a certain behavior were all on the roll. But it somehow makes sense to type those conditions to the role, to the behavior itself, sorry. And then you can have a more flexible and modular architecture. So we added 2 new conditions, namely the invocation and commitment condition. And the first one is when do we select that role, that behavior, and the second one is if it's still valid, can we still use that behavior or not? Then we introduced the arbitrator that basically has an input a set of behaviors, and then by priority it selects the one to use in that situation, basically using those conditions that are on each of those behaviors. The role now contains an arbitrator, and behaviors are added in the role constructor. And the decision also instantiates now all the roles in the constructor and selects them instead of instantiating it at each side. So some of the developed behaviors on this new architecture, we worked on ball passing, which is a real coordination challenge between two robots, and also we have the opponent team on the field. And now we have a new algorithm that takes advantage of the new platform grabbing system, which you might notice the difference between the old one and the new one is this grabbing system. This is basically a DC motor, which we could control on off, basically. And this one is much more sophisticated, and I think it was based on the TUE turtle robot. And we also take advantage of robot-to-robot communications, which we didn't before. So with this